So, hello, learners of physics. We are here for a brand new unboxing video. So exciting, so exciting. What is inside? Oh, normal stuff. Too bad.
Just batteries and multimeters.
Alright, so today we're going to focus on when you encounter a circuit and then you have a box with a lot of stuff inside, like this one. Actually, this is not all the stuff. We have more stuff, which will be coming to you very soon. But we're going to
Start with one simple cell.
Okay, one simple cell, that's right. This is a cell holder. Now, you might think that this is so deceptive, so easy, so plasticky, like a Lego. But do you know how to use it? GG, don't know, miss where to connect, what to do. Okay, now mind now. You see the spring here? Is it focusing? Focus.
It will take some time, but it will get there.
Just like some of us, right? Our
Yeah,
purpose in
lah,
life.
yeah.
Okay, sometimes we need to step a step away so
Okay,
that we can
can
see
ready.
our purpose in life. Okay, so spring, negative terminal. So a second problem here is, how do we know that this cell holder is working? In fact, we can test a few things at the same time. How do we know the meter is working? Normally during the exam, right, they will tell you what to use. But in case you want to check, what you can do is you can adjust the voltmeter setting to 20 volt, because you know what, this is a battery, it's supposed to be 1.5. So look at the decimal point. 2 decimal point should be good enough. So let me pop this up for you. There we go. Alright, so when we measure this, we are going to connect this directly. Okay, so you can see that there's a positive end here. So just connect this here, and we'll also connect this here. So if you check out the reading, this is 1.4, which is pretty healthy for a battery, which means everything here is working. The wire is working, battery is working, the cell holder is working. Very nice. So this is a good meter. I will put it in the good corner on my table. Alright, so now
Okay, then after that, check meter already, meter working, so okay already. What else to check? Your circuit why got so many battery holder? How to connect?
one is not enough, more is more. Less
okay.
is more is fake one, more is more. No, you follow the circuit. Okay, so what is the difference and why can they be detached this way? So sometimes we can connect the circuit like this. So normally if the cell holders is given to you like this, it's just 3 of this connected together. So just for you to understand, right, you can see that here and here are metal. So as long as the metal touch each other, we can consider that the circuit is connected. So of course we're going to connect the non-spring side to the spring side, metal touching metal.
Miss, what does the spring side mean? How you know whether to put battery inside? Which side? You see?
You use logic, or if you put this side into the spring, it will be caught up in the spring. No good. So you should put the flat side to the spring, because the spring will nicely fit into this groove. You see this groove here? Isn't this a spring-shaped groove? Aiyo.
Okay, so negative side got the groove, go to the spring side.
Yes. But I think we put the holder first lah.
Okay. Good to know.
Okay, so once I slide this in, you can see that the metals are connected to each other. I'm talking about all this, it might seem very trivial, but in case you intend to do a degree in sciences, not anyone is going to tell you how the equipment works, so you should know how to examine it on your own. I mean, not everything comes with a tutorial.
So many. So you can technically use this to connect as many batteries as you want. Since these are modular,
Yeah.
you can just take them apart, put together, all is okay.
Yep, so this one will be series. So let's say now I stick to 2 lah. Okay, and I'm just going to connect once again the spring to the negative terminal or the flat side, spring to the negative terminal or the flat side, and now with 2 batteries in series, this should give us a reading of 1.5 plus 1.5, which is 3-ish. I expect about 2.8, 2.7. So you can always, if you don't know where to connect, you can always try like this one. Oh yo, no reading. That means you shouldn't connect this way.
Wait, got reading already,
Got reading already.
See,
Okay, very good. So this is me just testing out the holder, making sure everything is tight. So this is healthy. Then you can start your experiment. You don't touch this one anymore. You don't touch these two connections. I mean, you're going to connect from here to here. Of course, if you were to connect, so just now, repeat, cannot the camera capture this. Okay. This is 2.8. Okay, this is 2.8. And if I connect this one to here, this is just one battery. So this is 1.4. So in series, it's easy to adjust. But what about parallel? How do we put circuits in? I mean, this kind of things in parallel.
Miss, you see this picture we put in the screen here.
Ah.
So actually this one, why got three stuck together in such a weird shape?
Oh, I put one because life is too boring.
So this one actually is parallel or series? Like just now you put two only ma, but then you go and add this extra thing here.
Why can't I add the extra
So
thing?
how is it? Okay, so if I look at the diagram, you can, just now you mentioned metal touch metal, right? So there should be a metal connection somewhere here, linking these two. Yeah, this blue color very hard to see. Never mind lah. Okay. Then there should be another metal. If you look carefully, that connects across these two like that. Looks like it all. You see? Actually, you cannot see it, but there's one metal there. So that means, wow, you connect like this. Then how? Like this. And then this one come down here like this. Wow, what kind of battery connection is this? Okay, so looks like you have connected it up here. So how to deal with this thing? What is this?
We measure lor.
If not sure what is parallel, what is series, let's check.
Measure lor. So if I connect these two, it means that I'm using these two batteries in parallel.
See, full battery is 1.5. This is about roughly 1.5.
So this one is parallel. Okay. So then this one will be in series. Right?
Okay, so from this part here, connect to the top.
So how would that look like in the circuit diagram? How to draw?
Miss experiment got parallel battery one, I never see before also.
I mean, sometimes can happen ma. Okay, so just now you have two batteries like this. Okay, and then another one in series this way. So in other words, if I were to draw it according to the picture that I see on your left right now, it will look like this. And this one is another one that is parallel.
In the middle, you have the battery here. Okay, so these two, how to circle? These two are in parallel. But if you think about this way, oh my goodness, this one is in series with those two on top. Okay, so something like this one.
So it's just generally how to use this modular cell holder. Alright. So now we're going to try to double check everything on the circuit. Cell holder works perfectly fine. I'm going to again put it in a good corner off camera. This is working fine. So now perhaps I would like to test all the other things that I will also be using in this particular experiment.
Okay.
Namely a bunch of resistors. So how do we measure resistor? Well, if you don't know the value of R, sometimes they were right here. They were very helpful. If you are like above and beyond, you actually know how to read the color band by memorizing the color, then good on you, because I don't remember these things. Alright, so we're going to adjust until maybe say 2 mega or 200K. Okay, look at this ammeter. Okay, green a bit hard to see. And then we'll just connect it directly. And I will expect the reading to reflect 3.3 kilo ohm lah, or somewhere. There we go.
3.3. Looks
Yeah.
good.
Yeah, if you can always test. Don't worry, it won't electrocute you. This one is fine, doesn't matter, as long as it's close enough. Alright, so this works. Where is the other battery? Oh, remember this?
The long chain of resistors.
Yeah, so how do I know all the connections are working? I test one by one. So I connect to the first one. These are all in series, obviously. So I'm going to check.
9 point. Wow, it's jumping around a lot. Put up a bit
Connection.
maybe.
Yeah. So it's around 1 kilo. How do I know it's kilo, miss? Look at this one.
20K it says there. So means 20 kilo is the maximum, is it?
Miss keep jumping when I move this one.
Wow, then you get this during experiment, then die. It keeps changing. Then your values is going to be very hard to read.
Yeah, so if you feel very not safe, you can just raise your hand and ask for help. Or if you think that, never mind, you see now quite stable already, right? So make sure you don't touch this anymore. So if I am kiasu, which sometimes I can be, I will always measure before I start taking the second reading but only if you have the extra time. There you go. So 2 1, 2 is around 2 kilo ohm. 3. This is just me testing and making sure that all the connections are okay. So this is 4-ish. This will be 5-ish. Doesn't have to be exact, as long as it's stable. 6-ish. 7.
So it's good. It's a good idea generally at the start of a circuit experiment. Don't just jump into trying to connect everything. Check everything. If not halfway, you have a headache trying to figure out what's broken.
Basically, get to know your toys.
Also, if you look at this part here, oftentimes people say, "Miss, my reading jumping around so much." So if you have your crocodile clip, it's a good idea to just clip it right on this solder joint, or even better, clip right on the resistor's arms itself.
But making sure that the thing is tight and not loose, because sometimes you will clip against the hole here.
Yeah, so your crocodile clip has holes lah. It's not perfect. So if the wire is so thin, then cannot already.
Yeah, actually wire thin also can. Just need to make sure it doesn't enter this hole. The wire.
The middle big hole lah.
Yeah, you see this big hole in the middle. See this one? No, cannot.
Use the zigzag area to clip the wires.
Yeah.
Or just clip this big bulb here lah. This one here.
So for best practices in circuit, we also need to measure the resistance of all the wire, because I'm going to expect all of this to be 0. If not, it gets sent into the naughty corner.
So I guess you firstly set your voltmeter to
20,
whatever lah,
200.
20K.
It doesn't matter because this one should read 0.
Ideally 0. So great, good wires, no resistance, no PD loss. Oh, 0, very good.
So this goes to the good corner. Repeat.
So yeah, we're just going to check through the wires.
Okay. I think if we insert a clock somewhere in the video, you always complain that, students like to complain that it takes a long time, but actually it doesn't. So this one looks a bit unstable just now, but now I think it looks, you see?
2.712.
So this one in the maybe corner.
So can change wire during experiment?
Can. You can just directly connect and then show the lecturer. But it shouldn't be the case. Like for example, this one also. Like
4.0.
I should think that there's something wrong here.
What is the meter itself wire got problem? Maybe, okay. Maybe power.
I don't like this wire. Look at this.
It's a bit loose.
It's like the crocodile is. This crocodile has short teeth. This crocodile. Oh, but can.
Come, this is the OK power. Yeah, I don't know. Students say very long, but actually I've seen some students, everyone doing the circuit, they are still there checking all their cables. And they have enough time, because circuit actually you can do very fast. So take your time to check. Make sure.
See this? What this?
Why got 1? Miss, what does 1 mean? You see on the
这个叫 maximum. Error 404.
So the reading is too big.
Like this.
Your meter cannot read it.
Because now the resistance between these two is air, and air has no resistance. And if I hold it,
still very big.
My resistance also still very big. Okay.
Okay.
So we're gonna, you know what? I'm gonna test everywhere. Most people keep telling me, oh, no time to test. I can talk to you, chit chat with Miss Ellie. Alright, so I think we have checked all the wires, and all these wires are ready to go.
These ones?
This one, I think these ones.
Okay,
we put one side, we put one side. Okay, you should organize your desk, but you probably don't have a camera and a writing tablet and another lab partner beside you.
Organize a bit crowded.
Yes, hi. Okay, so now we're going to try to connect a very basic circuit to measure the internal resistance. And I think I'm just going to put some batteries in series. Okay, so again in series. If let's say during the exam, whatever setup they give you, if they tell you to don't disassemble, then you don't disassemble, because don't give the lab assistant extra work to do. So later you accidentally break the plastic, then how? GG. So this one is in series, right? I'm gonna very quickly.
So you see this diagram here, they put the dot. Okay, all these dot means there may be more batteries lah.
TLDR, too much lazy to draw. Too lazy to draw.
So you just kind of have to read what voltage they want. Or they'll tell you lah. They'll tell you in lab.
Okay, let's say now I want. Ooh, I noticed something, Miss Ellie.
Oh, what notice?
Do you see?
It's leaking?
No, you see here?
A line?
It doesn't touch the metal.
Ooh.
If I press too hard. So you better make sure that the battery touch the metal. If not, you
see this?
try.
Right here?
Doesn't touch.
Battery not working means push down a bit now.
Yeah. So don't waste your experiment 5 minutes of time because there's only one experimenter per lab, and then later not working because of the way the battery is. So always check first. And so you can see this one is another case where it might not contact. So just adjust a bit lah. Make sure all the contacts are tight. Okay.
Spring not powerful enough.
So now just to double check, we are going to connect this directly. So it should register. I will check through, and it should register. Again, we adjust this one to, I don't know, 20 volt. Okay. So
okay, connect. So what does the reading say?
4.2.
4.2 for 3 batteries considered okay or not?
Okay
You check see 1.5 per battery. 3 batteries means should be maximum 4.5. So 4.2 seems reasonable. Okay.
Okay, can start now. So we're going to use everything from end to end. But we also need to have 2 meters. So ta-da, enter meter number 2. But means all the meter look different. Need to memorize. You don't need to memorize. You can read what. Okay.
Please connect properly. Anyway, change this one again. Okay.
Alright, so here I'm going to use this as an ammeter, but before I use it as an ammeter, I just want to check whether the connections are working or not. So I'm going to repeat the process again by expecting 4.2 volt here. If I don't get 4.2, something is wrong.
So it's also a good idea why we're doing ammeter first. The voltmeter you do later. Ammeter first. Okay,
so
check.
4.22. Okay, just now 4.2, 4.19. Okay lah, can. Means why different one? Uncertainty ma.
Your meter, my meter, a bit different.
Plus minus uncertainty
Okay.
Alright,
so both working. So that one is the ammeter, this one voltmeter lor.
Okay lor.
So they will tell you what setting to use at the start of lab. So please make sure you don't blur lah. Okay, I assume 2 volts. I'm gonna choose 2. Oh, you cannot 2 volts, 20 volts.
20 because got 3 battery.
Okay, so we have 3 batteries. So I'm gonna choose 20 volts because 2 volts will just, I don't know, may not be enough.
Ammeter leh, decay right? Never mind, we connect first.
You connect and then you will see which one to use.
Okay, so now we're going to start connecting. Of course, the internal resistor is part of the battery already. We're going to connect small r. We'll just connect this one directly to the... Okay, if you want to be like a pro circuit person, right, you will always start from the positive, and the positive is always red. Okay? So red side is where the current exit. This is how you check circuit law. You check where the current exit your power supply, which is here, okay? And then it will go into the ammeter, okay? So enter the ammeter, red connection, exit the ammeter, and then so all the exiting ones should be black lah. But next part is your variable, is your resistor. I think I will use this variable resistor. Okay. Wait, adjusting camera. Should I keep talking?
Yeah, you can continue.
Okay. So this one is 1. Yeah. So this is our variable.
It's a bunch of resistors lah. So can lah.
It's not really. I prefer a continuously variable resistor, not a discrete variable. Okay, never mind. Too much math.
Okay, so we come down here to ammeter. So that's coming down here.
So enter the ammeter. Exit
From ammeter, you can follow, and then go to your, ignore the voltmeter first, go to your variable resistor. So that's the whole chain of long resistors over here. Next, what next?
So little black wire.
So now we're exiting.
The color doesn't matter. So exiting, this is to return back to the power supply. We have completed through all the components in the circuit. So we're going to connect loop by loop. Like say, for example, we're ignoring the voltmeter first. Because, divide and conquer. So So everything looks good. We have returned back. So now the question remains, how do I connect? I think we can connect the voltmeter first.
Now can already? Okay. So incoming voltmeter. Put down here lah.
So note that I have also used all the value of the resistance because I just want to see what are the ranges of my reading, and then if needed adjust my voltmeter accordingly. You probably don't need to do this because we do a lot of spoon feeding lah, and also so that the graph all look the same. So we will tell you what setting to use. So sad, right? It's okay. You can always use some of your circuit knowledge to know whether you connect correct or not. So that's why we know that, okay, this circuit is fine because when I decrease the value of R, I use less resistor, my ammeter reading increases. But if you cannot brain, then you just trust yourself.
So basically you're just testing out the values. The largest resistor should have smallest current. Smallest resistor.
We're checking for trend, the trend mark, making sure the trend mark makes sense.
So if during labs or practical you get, let's say we look at all these apparatus, right? Maybe you get another meter that looks different. It's still a meter. You just need to know which knob to turn.
Read the label.
Okay. So one section is usually for, what is this called section? Okay, this one you see DCV voltage.
Can zoom
Can. Zoom and see? Can zoom in, see some. Whoa, can see. Okay.
Okay.
So you see lah, DCV, whatever meter you get in any part of the world, in any country, in any lab, you look for a voltage section.
Direct current voltage. That's DCV, right?
Yes.
ACV is alternating current voltage.
Then you go to the right side. DCA is what? Direct current. What's A?
Ammeter?
Can.
Apple?
A for ammeter.
Alligator.
Okay. So this is the small, to read very small current. Okay.
Then
10 amps usually you will not use.
Thick currents.
Big currents. Okay
Big currents.
Large current. So usually
THICC.
I think during labs will be somewhere here 20. Roughly. They will tell you.
They should tell you.
So you pay attention. If they give announcement at the
They
beginning,
will also write
they
very
say.
big on the board.
If you cannot hear, cannot see, then I cannot help you already lah.
Make sure you sleep enough or pay attention. I want to say open your ears, but that makes no sense.
Cannot open your ears. Your ears already open. Okay. Last one is this down here. You will see a ohm. Ohm is what? Ohm is resistance.
This one is seldom used.
It's more for you to check, like what we used just now.
But there was once we used for LDR, remember?
Yeah, that one is okay lah. Can just so you know different section of the meter you turn, you have different settings.
The alternating current one.
No, they don't think you will use it, right?
A2.
A2 got lab meh? Wow,
We pretend got lab, but you just write only.
Okay. One thing I must warn you about is on the meter you will see a whole button. This whole button is a troll. A lot of students will tell me, Miss, I connect my meter reading not changing, it's always 0. Excuse me, you double check. If your top corner of your screen got a H, that means you have screenshot frozen your reading. So you press the whole button, unhold it.
Don't hold on to things too tightly.
Okay.
Must let it go.
You be careful if you see a H in the corner of your screen, that means your reading is frozen. Just unhold it. Stay calm. Okay. If you have something different, maybe like this, same thing. You just have to stare at it very closely and try to look for what makes sense. So you see left side, here got V everywhere. How to?
But where is the AC/DC, miss?
Don't have.
Look, can I look at the dotted line?
Maybe can. What is the dotted line means?
Negative 4. Full line is positive 4.
Okay, so looks like here is gonna be your DC.
Yeah, because the other one like a wave.
The other side here is like that. Wavy means don't worry about that. AC. So you're gonna use probably 2 volt, 20 volt, 200 milli up to you.
Yeah.
Not 200.
Another hint would be, you don't have a way to measure AC current using a meter like this.
Have to use CRO.
Yeah. So whatever symbol you use for B
AC.
and A, it should have.
AC
they are
is
both
like this
DC
one.
Yeah.
AC the current will
Yeah, I think we haven't talked about that wire yet.
We will talk about the wire in a bit.
Okay, we need to talk about the wire.
Okay. So you get the idea, your setting, okay? You check your your setting, please don't be blur, they'll tell you. And if got hold button, you make sure you don't hold your
Just don't panic. Slowly connect. Check everything first, then connect. If you connect already, you check everything, you really think that there's no way, and then it's already like, let's say 15 to 20 minutes into the experiment, you just raise your hand. It's okay to lose 1 or 2 marks than to not be able to conduct the whole
Everything wrong.
experiment. And it's gg.com.
Yeah lah. So same thing lah, like we mentioned, just to recap. You got battery, you're not sure. This one obviously they tell you 1.5 and 3 volt. But if you have something that is this kind of thing, they won't tell you. So you take your voltmeter and you test.
Yeah, you can test with the voltmeter.
Like what we did just now, you scroll back, rewind the video, test lah.
Yeah, let's say I don't know, test no, you connect
So like
and test.
this one here, maybe you see black color. Okay, black color probably means negative. You connect there.
Oh, not in my box,
That was a new one, or old one detect
only this one.
something like that. That one obvious this one is this one here. This one obviously lah. They already write here 1.5. Okay, so if you want 1.5, you connect across like that.
But see, sometimes you check the wire at the back, maybe some connection got problem. You don't know one.
Yeah.
So before your exams, the lab assistant will do their best to check every single thing. But at the same time, they are checking for maybe 1 to 200 setup.
Too many already.
So confirm will have maybe 1 or 2 unlucky or very lucky one. So you just check. If got, definitely we will replace it. There's no penalty one. If let's say there's a problem with your circuit, we went and check, and it's because of the component error, you will be reimbursed with a brand new one.
Yes. Also, chances are if they give you 2 battery, usually you use both lah. But you must check your instructions.
Just
But
use,
chances are if they give you both, use both. Okay.
just read the instruction carefully, slowly. Means why always jump one? Should I
Steady,
connect it
yeah.
in a certain way on my wire so that it doesn't jump?
Oh, good point. Okay.
Jump
So
here,
one
jump
of
there.
the uncertainty maybe all this part down here.
See, if we tap and tap.
So if you look at this picture here, I try to zoom in so you can see in all this kind of wire experiment, there's a lot of possible loose connections. So I guess the best, you may say the best means I just kiap here, connect here my crocodile clip. But then the wire is so thin, maybe your crocodile clip is loose. So how? To make sure it's tight.
Try my best.
Okay. If you clip in this red color thing, maybe the connection inside here is loose, then you also have problem.
You also wouldn't know.
So you wouldn't know. So it's, you really have to double check, like pinch it tight, check, move the thing a bit, is it tight? But if you can, try to connect on the wire itself here. So reduce the number of connections. I guess you could, if you want to clip on this screw nut, what is this called? Bolt nut. Also can.
And then I don't know whether you noticed or not, when I disconnected and reconnected the circuit, I lost my 0.2. Now it's around 0.16. So this also means that once you connect your circuit, you have to immediately take all your readings.
The
Don't
faster
connect,
the better.
The faster the better, because the wire will get hot or some other thing will happen. So the faster you connect, faster you take readings, because you only need 6 right? Then the better it is for your experiment. And if you want to take repeated reading, you shouldn't, let's say you start from 10 cm to 100 cm, you shouldn't restart from 10 to 100. You should just put at 10, take the reading, and then disconnect, connect back at 10, and then take the reading again.
So like connect, read.
So the
Connect, read.
timing matters. So you should just do the experiment as fast as possible, and you can see now it has dropped from 0.16668
Drop to 1.61 already.
yeah. So you see, as we talk, the
Your value will change. So don't take your sweet time for circuit. Just
yes. So you connect everything, you're okay. That's why take the time to check, but do not take your time to take the reading. Understand?
You know, there was this one student I noticed.
Yes. Tell me.
The circuit cannot work for 40 minutes.
Oh.
She's just like, but didn't ask for help. Then
Tragedy.
finally, 45 minutes later, the student asked for help. Then found out, it's a 40 voltmeter. Okay, change. So the student in the end have like 10 minutes left for question 1. So the student do what? Speed, connect everything.
Because the student probably already looked at the circuit 8 to 10 times, check, or CFCC, can memorize the circuit already, so can connect very fast.
But the point is very interesting. This student took like less than 10 minutes to take all the reading, and the graph was perfect straight line. So can do experiment in 10 minutes.
Because she did the experiment and she took the reading very fast.
So no shit, it's like perfect.
Yes,
It's like,
because you remember she had 10 minutes, so she quickly took her reading. You know, you have to be look at this reading.
drop until what? 0.148. Wow, talk some more lah. Wait until the reading all change, then you see your graph become curved already.
Yeah, or you feel like, I don't know whether correct or not. Look at the friend.
I don't look lah.
Oh, cannot look CIE exam later your name kena, then nobody can help you already.
So take fast reading.
Post also cannot help you. Okay, so that's all. Right?
Okay, that's all.
Okay.
So that's all for circuits. You need to take some notes from today's video, just go and rewind, take some notes.
Yeah, because you cannot bring this video into the
Quarantine
room with you. If you're wondering why it decreased, because the wire become hot.
Wire become hot, then what will
Then all
change?
the reading will disturb already. Okay, so just do reading fast. Okay, that's all.
Yes.
Sekian.
So to summarize, number 1,
Yes.
check circuits and components.
Check cell holder.
Everything you can check, you check. And this one you can take your time to check. But don't take the whole 1 hour to check. Okay. Then number 2, when you connect tight. Every single thing you clip must be tight.
Yes, as tight as you and your BFF.
Okay, can. Number 3, now it's time to do reading. You read like as fast as you can.
Yes, like the Flash. Just.
So like bzzz,
I mean fast, but you don't go and like drop things or stuff like that. Like, you know?
But also, by the way, number 4, if you need help, get help.
Yeah. Please get help. If let's say by the 20-25 minute mark, your circuit still not okay, everything not okay, then you just get help lah.
So around 30 minutes, if your circuit still cannot, then faster get help lah.
Yeah.
If not, then you try to troubleshoot. Okay, so these 4 ideas, you just use this for doing circuit experiment in general. If you come across it in labs or in exams,
Yes.
this is it.
And don't worry, it won't electrocute you. Generally, I also the less wire, the less components, the less connection, the more stable your reading will be. So those of you who like to connect a lot of wire try to summarize your wire. Use less.
Sounds good. Sounds good. Reduce number of connections. Okay lah, add here lah. Connect tight. Reduce connections if possible. Okay now, 4 tips for you already. What else you want to do? I go and see all the picture lah. Okay, so that is all for today's video.
Okay, see you in the next one, guys.
Bye bye.